Hey guys, in this video we are going to talk about how to find compound probabilities and differentiate between independent and dependent events. But first, let's just break down some of the basic vocabulary. So probability is the measure of how likely an event is to occur. So when you wake up in the morning and you check the weather report and you see that there's a 30% chance of rain, that's a fairly unlikely event. But you would never ever see that there's a 120% chance of rain or a negative 10% chance of rain. So one of the things we need to pay attention to is that probability is always between 0 and 1. Or you can think about it in terms of percentage, 0% and 100%. So keep in mind, you probably have learned a little bit about probability in the past. You can represent probability in 3 different ways. You can use fractions, that would put it between 0 and 1. You could use decimals, which puts it between 0 and 1. Or you can identify probability using percentages, so 0% and 100%. A sample space is the set of all possible outcomes. Theoretical probability, this is what we're most used to working with, is the ratio of the number of favorable outcomes to the total number of possible outcomes. So here's our formula. We have P of E. So when you read this, you say P of E, which just means the probability of some event E happening is the favorable outcomes over the total possible outcomes. There's another type of probability called experimental probability, and that's when you actually go through an experiment and you calculate, okay, how many times did I flip the coin? 50 times. How many times did heads actually show up? Well, heads actually ended up showing up 30 times. That would be an experimental probability, then would be 30 out of 50. But we're just going to focus on theoretical probability for right now. So let's look at some examples. So this is what's called an example of a simple event. So these are the types of probabilities that tend to be very intuitive to us, that we're kind of used to thinking about. So we have a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So first we need to figure out how many total marbles are there. So I take and figure out the total. So I take 32 plus 28, meaning there are 60 marbles in this jar. 32 of them are red, and I'm interested in drawing a red marble, over 60 total marbles. Simplify the fraction if you can. Both are divisible by 4. So we have an 8 out of 15 chance of drawing a red marble. Or again, remember, you could represent this as a decimal. We're going to do 4 decimal places, so 0.5333. Or you can write it as a percent. So remember to do that. You can either take the decimal and multiply it by 100 because percent is 100, or percent is out of 100. Or you can take and move the decimal 2 places to the right to end up with 53.33%. Let's look at example B. A letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So you need to figure out how many total letters are there. So if you go through and you count all the letters, there are 11 letters in total. A vowel, remember those are A, E, I, O, U's. So I have 1, 2, 3, 4, 5 vowels. So I have a 5 out of 11 chance of selecting a vowel. This fraction does not simplify, so that would be our answer. Or again, you can represent it as a decimal. Or as a percent by taking that decimal and moving it 2 places to the right to get 45.45%. Last example, what is the probability of drawing a heart or a club from a standard deck of cards? So let's just really quickly kind of break down what a standard deck of cards entails. There are 52 total cards in a deck. And in a deck, you have 4 suits. Okay, and of those suits, you have 13 hearts. These are red cards. You have 13 diamonds, also red cards. You have 13 clubs, which look a little bit something like this, and they're black cards. And then you have 13 clubs. Sorry, this was a spade. So 13 spades, and then 13 clubs look a little bit like a 3-leaf clover. That would be a club. And then you also have an ace card. And then you have numbers 2 through 10. And then you have a jack, a queen, and a king. The jack, queen, and king are what are called face cards. And then depending on what game you're playing or who you're playing with, the ace is either a low card or a high card. So just kind of a review of a deck of cards or a standard deck of cards that will help you moving forward, as decks of cards are used a lot in probability problems. So we want to know the probability of drawing a heart. Well, there are 13 hearts according to my math here. And I have 13 clubs and 52 total cards. So 52 total cards, 13 hearts, plus 13 clubs, right? So I have 26 cards then that would be either a heart or a club out of the 52 cards in the deck. That fraction simplifies. Both the top and the bottom are divisible by 26. So I have a 1 out of 2 chance of drawing a heart or a club, or as a decimal would be 0.5. And then as a percent, it would be 50%. All right, perfect, guys. That was just kind of a quick review of some simple events and probability. Until next time.